Hello everyone, I'm Yuichi Omozaki from Osaka Prefecture University, Japan. I'd like to talk about our evolutionary approach to optimize a fuzzy markup language-based inference system.
Fuzzy Markup Language (FML) in short, is composed of the knowledge base and the rule base. The knowledge base is represented by several fuzzy sets, and the rule base is represented by a set of fuzzy if-then rules. Using FML, researchers can define various fuzzy systems without depending on the software. We use a specialized Java library called JFML in this competition. In FML-based machine learning competition, 60 game results of AlphaGo Master Series are provided. The goal is to design a good fuzzy inference system which predicts the win rate calculated by the ELF OpenGo AI. 60 games are divided into 45 games for training and 15 games for testing. Each game data includes patterns composed of 6 attributes and 1 output. In our proposal method, we use a genetic algorithm to optimize a fuzzy inference system. First, the rule base is optimized using the predefined knowledge base. Then, the knowledge base is optimized using the best individual in the previous phase. After that, the rule-based optimization phase is performed again. In this way, the two phases are alternately performed using the best individual in the previous phase. Okay, let me explain the rule-based optimization phase. This is our initial knowledge base. An initial population is generated using this predefined knowledge base. Before starting the evolutionary process, we divide the training data into the learning subset and the evaluation subset. Then we generate fuzzy if-then rules for covering a pattern randomly selected from the learning subset. After generating population, we calculate the consequent part of each rule in an individual using the learning subset. Then we calculate the MSE values as a fitness value of an individual using only the evaluation subset. By crossover, new individuals inherit some rules at random from two parents. Then, by mutation, a few fuzzy sets are replaced with another fuzzy set or don't care. Finally, we update the population based on mu plus mu ES strategy. Next, let me explain the knowledge-based optimization phase. First, an initial population of the knowledge base is generated by adding random perturbations to the mean and variance of membership functions. Then, the genetic operators are executed. A new individual is generated by single-point crossover from two parents, and mutation is performed randomly by perturbing to each parameter. Finally, the population is updated by mu plus mu ES strategy. I'd like to show that our experimental results. These are the experimental settings. This shows the evolutionary progress of our proposed method. The green line represents the MSE value for the evaluation subset. This indicates that our proposed method is working well. The red line represents the MSE value for the test dataset. We can see that the generalization ability is improved. These plots show that the obtained knowledge base in the final generation. We can see that the shapes of membership functions were tuned to optimize the fuzzy inference system. These figures show that the inferred win rates for the training dataset and the test dataset. As you can see, several parts of the test dataset is difficult to infer. The similar results were observed in some trials. We also examined the performance of the fuzzy inference system composed of all combinations of the antecedent parts. The obtained model by our proposed method was not so accurate but very simple. There is a clear trade-off between the accuracy and the complexity of the fuzzy system. we proposed a GA-based fuzzy inference system for the FML-based machine learning competition, and we optimized the knowledge base and the rule base by applying two optimization phases alternately. As the future work, we should improve not only the accuracy but also the explainability of the fuzzy inference system, and we should analyze the optimal shapes of membership functions in detail. Thank you very much for your kind attention.